if we divide a number by another number, we may get what we call a remainder. In our case, we are dividing 3x cubed plus 2x squared plus 4x minus 6. We are dividing that by x plus 3. So our dividend is 3x cubed plus 2x squared plus 4x minus 6. And our divisor is x plus 3. So the remainder theorem is simply saying, if you have a function of x and you divide it by another function, x minus a, your remainder is f of a. So you need to know a first. So when you're using the remainder theorem in our case, we have to know f of x and our a. Our f of x is clear. We know what is our f of x. So f of x, we know it. This is our 3x cubed plus, so f of x is equal to 3x cubed plus 2x squared plus 4x minus a 6. We know this f of x, but we don't know our a. We have to find our a. So you find a first, then you find f of a, which is our remainder. This is our remainder. So all you need to do is to know your f of x, find a, and find f of a, which is the remainder. So I'm going to rewrite my question and show you step by step how you calculate the remainder here if you are given a function of x and its divisor. So let's do that. So f of x is 3. So f of x is 3x cubed plus 2x squared plus 4x minus a 6. This is our f of x. If we want to find our a, we take our divisor, we equate it to 0, and we solve for the x. So our divisor is x plus 3. This is our divisor, x plus 3. We say it is equals to 0. Then we solve for x. What we get is our a. So x is equals to minus 3. This tells you that, therefore, a is equals to 3. So you have solved the first part of this question, which is finding the a. Once you have your a, you can now find your f of a, which is your remainder. So I can write here that my remainder, from the remainder theorem, I know that my remainder is f of a. F of a is f of x with x replaced or substituted by the 3, which is our a. So every place where there is x in our f of x, we are going to put a. So we're going to take this 3, we put it here for x, we put it here for x, we put it here for x. Then we get our f of a. So I'm going to write f of a. It means 3 by, sorry, our a is minus 3. So it's 3 by minus 3 cubed plus 2 by minus 3 squared plus 4 by minus 3, then minus the 6. This is our remainder. All we do from now is just punching in our calculator what we have, and we get our remainder. So this is to the power 3 plus 2 minus 3 squared plus 4 times a minus 3 minus 6. We get our remainder, which is minus 81. This is our remainder. So we have solved this question using the remainder theorem. We go to our divisor, we equate it to 0, we solve for x. What we get there as our x is actually the a that we're going to use. So I'm going to do another example. We have, so the question is still the same. Calculate the remainder, calculate the remainder if So our dividend is 4x squared plus 6x minus 4, and this one is divided by, we're dividing this, is divided by 3x minus 5. So we're dividing this by 3x minus 5. 3x minus 5. We want to find the remainder. This here is our divisor. This is our divisor. This is our dividend. The number that we're dividing into, we call it the dividend. Okay. As usual, you need to find your A, then you find your f of A, that which is your remainder. Okay. So it's quite a straightforward issue. It's quite a straightforward issue. To find our A, we take our divisor, we equate it to 0, then we solve for x. So 3x minus 5 is equals to 0. From here we solve for x, therefore x is equal to 5 over 3. This is our x, and it also happens to be our A. So now we have A is 5 over 3. So our f of x, we know our f of x, that's the function, that's our f of x. This is our f of x. Our remainder that we're looking for, the remainder, is simply f of A. And I will repeat again, f of A is just f of x with x replaced by A. So we're going to substitute our A here into that f of x for us to get the remainder. That's what we all need to do. So I'm going to rewrite this clearly and show you step by step what you should do. So let's go to f of x, which is equal to 4x squared plus 6x minus 4. This is our f of x, and we agreed that our A is 5 over 3. That is our A, and we know from experience that f of A, in fact, let me write it like this. We know that our remainder is f of A. So the remainder here is f of A according to the remainder theorem. This is our remainder, f of A. And what it means, if you understand functional notation, it means in f of x, we are going to replace x by our A. So in our case, this is f of 5 over 3. Every place in this, everywhere where there's an x, we are going to put 5 over 3. That is what it means when you say f of 5 over 3. So this is 4, 5 over 3 squared plus a 6 multiplied by 5 over 3 minus a 4. We punch this in our calculator. That is our remainder. So we have 4 and 5 over 3 squared. 4 times 5 over 3 squared plus a 6 multiplied by 5 over 3 minus 4. That is our remainder. I get 154 over 9. 154 over 9. Let me use a different pen. So this is 154 over 9 over 9. Or if we write it to 3 decimal places, that is 17.111. That's our remainder. As long as our A is correct and we evaluated our f of A correctly, then we'll get our remainder also as the correct one, 154 over 9. All right. There are times when you are going to use the remainder theorem in reverse. You might be given the remainder itself, and you are given the divisor, and then you are given the dividend with some letter that they want you to solve. You can just use the remainder theorem in reverse, where you know that, oh, f of a from your divisor gives you the remainder. Then you solve for the missing letter. There are times when you are required to do that. I'm going to do another video where I explain the applications of the remainder theorem. But for now, I was just highlighting what the remainder theorem means and how you get the remainder if you're given the dividend and the divisor. Otherwise, thank you for watching. You can subscribe to the channel. Thank you.